All right, so let's get back to our original goal for these videos, which was to solve one-step logarithmic equations. The last video was intended to build up your intuition a bit more, kind of discuss what a logarithm actually is. In this video, we're going to attempt to accomplish the goal of solving one-step logarithmic equations. Before we do that, however, I do have to define one other concept or remind you of one other concept, and that is what to do when you have a fractional exponent. Now this is something you probably saw before, either in Algebra 1 or Algebra 2, but since it's been a while, I like to always double check that we remember how to do these. So let's just say I wrote down that I have 16 to the power of 1/2. Well, what this means is actually that I'm taking the square root of 16, which is just 4. And you can always double check that on your calculator. So if you do 16 to the power of 1 divided by 2, notice there I get 4. And so that shows me that this is the square root of 16. So that tells me that if I had something like, let's say, let's do 60, no, I don't want, yeah, 64. 64 to the power of 1/3. This means I'm looking for the cube root of 64. Cube root might be, again, a little bit, it might be something you've kind of forgotten. This just means I'm looking for a number so that when I multiply it by itself 3 times instead of just 2 times, I should get the answer. So if we look at our calculator again, we could do 64 to the power of 1/3. And actually I get 4 again in this case. I built it that way. And so what this means is that if you do 4 times 4 times 4, or if you do 4 cubed, you should get 64. So really what this is saying is if I have any x to the power of 1 over n, this is just, we call that the nth root of x. And the reason we're going to be doing this is if I have to solve equations that look kind of like this, let's say x to the 5th equals 2,133, we'll say. In order to solve this, you can either take the 5th root, which is sometimes kind of inconvenient on a calculator. So another way you could do it is instead you could say 2,133 to the power of 1/5. You'd get your calculator out. 133 to the power of 1/5. And we get about 4.632, we'll say. And so that would be my answer in this case. Now the reason I introduce or reintroduce this topic in this section is because if we go back to logarithms and I were to ask you, well, what is log base 9, I almost flipped this, log base 9 of 3. Remember in the last video we said I'm looking for some number, which I'll just call x, such that this equation is true. 9 to the power of x, using the definition of a logarithm, equals 3. So I'm using this definition. If I have b to the power of x equals something like y, this is the same as x equals log base b of y. And these x's and y's just represent anything. They could be switched. They could be different letters. They could be numbers. But the point is that if you're following along here, everything has the spot that it needs to go. So x is really the exponent for 9. And so the question now is, well, how do you get 3? Well, we just figured this out. The square root of 9 is 3. So that means that 9 to the power of 1/2 would be 3. So in this case, I shouldn't use x. I should go back to the original problem. Log base 9 of 3 actually equals 1/2. Now this is also a good time to show you a bit more with the calculator. Once again, we haven't quite gotten into solving one-step equations yet. We're still building up to that. But let's go back to our calculator here. If you were trying to do log base 9, you don't really have a log button. So I don't see log anywhere over here. If I click ABC, I could type in log. But then there's no way to do base 9. If you're looking on here for some sort of base, I don't see any way to get a base 9. Alternatively, you might look at the func button, the functions. And again, there is a log, but I can't change the base. There's also a natural log, and I can't change the base. So one thing you could do is go to the graphing calculator, and you can actually do log of any base on this one. I think it's in, yeah, you have to go here, whoops, log, and then you can go in the bottom left there, you see the A with the little B next to it. If you do that, you can change the base. So again, that's next to the 1, 2, 3 button, A with a little B next to it. Now I can go back to the numbers and I could actually put 9 there, hit the arrow all the way to the right of 3, and that tells me the answer right there. It's actually 0.5. Now let's go back over to here, see how this doesn't actually have that A with a little B next to it. So if you want to do this on the calculator, you can use the Desmos graphing calculator to do it. All right, so let's get into the actual objective today, which is to solve some logarithmic equations. So we're going to solve for x in each of the following. And in order to do that, I really want to make sure we have this ingrained in our memory because we're going to keep referring to this. Although the letters will change, this is going to be our holy grail here of math in this next part. So here's the first problem. Log base x of 81 equals 4. Log base x of 81 equals 4. So notice my x value is actually in a different spot in this formula. So the x value is actually taking the place of the b. So when I convert it to an exponential, that's going to be my base. It's going to be x. Now the y in this case is actually the what's inside the parentheses here, so the 81. So we're going to have equals 81, and then the exponent, the x value in this, keep in mind that's what's over by itself over here, so that's going to be the 4. So when we convert this, and you'll get better as you see the pattern developing, one thing that I always do is I take b to the power of this, and then that's kind of how it works in my head. But you'll develop your own patterns as you go. You'll start to understand where everything falls. So x to the power of 4 equals 81. Well, now we have to solve this equation, which is not logarithmic, it's not exponential. In order to solve this, we're going to take the 4th root of both sides. Let me actually do that on another line so I don't get too mixed up here with the notes. So the 4th root of x to the 4th equals the 4th root of 81. And so now what I can do is I can plug this into the calculator, and you can take a 4th root on the calculator, which you could use that n with a root on it to get, and you have 81. You would get 3, or you could do 81 to the power of 1/4, and you would get 3. So that means that the answer in this case is 3. And you could always go back and check your work on Desmos. So this is just a chance for me to remind you all about what I just showed you. So we're kind of wondering log base 3 of 81. We want to make sure that this does in fact equal 4. So you go on Desmos here, graphing calculator. We're going to go log with the base button in the bottom right, base 3 of 81, and it does in fact equal 4. So we did it correctly. Okay, so this problem, the x was in the base of the logarithm. In the next one, we're going to switch it up a little bit and put the x over here. But the first step remains the same. The first step I need to do is convert it into an exponential equation so that I can get access to that x. So I'm going to take 7, that's going to be my base, to the power of the 3 over there equals x. And actually this is really the answer. We just have to plug this into the calculator. So if we go over here, we say, well, what is 7 to the power of 3? Well, that's just 343. So keep in mind, these are, I'm calling them one-step logarithmic equations. Some of them, I guess that one kind of took a little bit more than one step. But these are sort of the level one, so if it doesn't feel like there's a lot of work, that's good. There isn't a lot of work in solving these. It's more focused on developing the concept rather than giving you a lot of work on these problems. Okay, now the last one you might see, it's almost a trick question, and I'll show you why in a moment. Log base 4 of 64 equals x. We actually already did one very similar to this. Now, this one we actually don't have to convert because we already have the answer. It's right here, whatever log base 4 of 64 is. If you want to convert, so you might say, well, 4 to the power of x equals 64. That might help you understand what x has to be, because you could do what we saw in the last video and start thinking about what these are. And then you might know that 4 cubed is 64. So therefore x is 3. Or what you could do, if you weren't sure, maybe it's harder to do this in your head, you could just go to Desmos and you might just type log, log base 4. This takes me a little while on here because I don't have a keyboard for my iPad. 64. And you would end up with 3. And that's exactly what we said, x equals 3. So that is actually the end of our videos. You can now hopefully solve one-step logarithmic equations. I'll just call them log equations. So that was our goal. And at this point, I think you're ready to do the practice in Delta Math.